In Standard 3, we'll learn how to solve equations with variables on both sides. This is a lot like Standard 2. You clear the parentheses, you combine like terms, except now since there's variables on both sides of the equation, we'll have to combine like terms on each side separately, and then we'll have to move all of the variables over to one side. And then same as before, we'll use addition or subtraction to undo, and then multiplication or division to undo. So let's try this first one. Let's leave the steps. So I will clear the parentheses first. So negative 3 times x is negative 3x, and negative 3 times negative 4 is plus 12, plus 2 stays there, equals 4x. I'm going to think of the minus 5 as a negative 5, and then distribute the negative 5 through the parentheses. So that's going to give me minus 5x, and then negative 5 times 6 is minus 30. So now I'll combine like terms on each side. So 12 and 2 are both numbers, so I'll combine those to get 14. And on this side, I'm going to combine 4x minus 5x. 4 minus 5 is negative 1, so that's negative 1x, or just negative x. And then I still have the minus 30. Next, I'm going to get all of the variables on one side. I'll do that by either adding 3x to cancel out the negative 3x on the left, or 1x to cancel out the negative x on the right. I'm going to choose adding 3x because then I'll end up with a positive coefficient of x on the right-hand side. So plus 3x and plus 3x. That's going to give me 14 on the left-hand side. The 3x and the negative 3x cancel out. And then 2x minus 30. So next I'll use addition or subtraction to undo. And I'm trying to get this x peeled back all by itself, so I'm going to add the 30 to get rid of all the other things on the same side the x is on. So that's going to give me 44 on the left-hand side and 2x on the right side. Next I'll divide each side by 2. So I get 22 equals x. Sometimes, because you have a variable on both sides, you can have a situation where you don't have an answer at all. As it's going to turn out, there's going to be no number for x that's going to make this equation true. So let's see how that could possibly work out. So first of all, I'm going to clear the parentheses. So 4x plus distribute, that gives me 5x plus 5. It's going to equal 3x. Once again, I'm going to think of the negative as going with the 3 and just distribute that through. So negative 3 times negative 2 is plus 6x, and negative 3 times 7 is negative 21. Combine like terms on each side. So 4x plus 5x is 9x plus 5. Over here I have 3x plus 6x, which is also 9x, and this time it's minus 21. So it looks a little bit weird here. I have a 9x on each side, so it seems like my only choice is to subtract 9x, so I'll do that. And then what I get left is this weird looking thing, 5 equals negative 21. But we all know 5 does not equal negative 21. That means there's a problem with the equation I set up in the first place. There is no value for x that's going to make that equation true. So we say this equation has no solution. So if I was to just make up some value for x and put it in the original equation, let's see what would happen. Let's say I picked x equals 2. So 4 times 2 plus 5 times 2 plus 1 equals 3 times 2 minus 3 times negative 2 times 2 plus 7. So 4 times 2 is 8. And I'll do what's in the parentheses first. So I've got 5 times 3 equals 3 times 2 is 6. Minus 3, I'll do what's in the parentheses again. Minus 2 times 2 is negative 4. Plus 7, that's 3. So 8 plus 15 equals 6 minus 9. So 8 plus 15 is 23. 6 minus 9 is negative 3. That just doesn't make sense. it would be really boring to watch me pick every number in the universe and try and put them into that equation. So you're just going to have to trust me on this, that any number you pick for x is not going to work. So this equation has no solution. Let's try another one. There's going to be something fishy about this equation too. So first I'll use the distributive property. 10x plus 6 minus 8x equals 9x plus 6 minus 7x. Then combining like terms on each side, 10x minus 8x is 2x plus 6. Over here, 9x minus 7x is also 2x plus 6. So yeah, same kind of problem. I'm going to subtract 2x from each side, and I'm left with 6 equals 6. This is different from the last equation. 6 will always equal 6. So the way I set up this equation, it doesn't matter what number I put in for x, it's going to be a solution, because I'll always get something that's true. So the answer for this equation is all real numbers. So any number you can think of that you stick in there would work for that equation.